Welcome to the second video in the same series of machine learning. Here we are going to learn about a fantastic concept of data pipelines in machine learning. So pipelines, as it's obvious from the word, that they are supposed to put the data into a pipeline kind of format and produce the final output. Let the data go through a set of filters. Filters will categorize the data as if it's categorical or numerical. We'll apply some methods to it, that is imputing the missing, apply one-hot encoding on both categorical and numerical data, and finally producing the transformed output. In our previous video, we did all these steps manually, step by step, one by one. We tried to identify the categorical columns by ourselves and numerical columns by ourselves. Now in this method, in this video, we are going to do this programmatically using data pipelines. I'm giving a set of steps to the program, to Python, so it will perform the set of steps and produce the final output. In a way, this is a simple example of short automation using Python. So let's go ahead and get started. What you see on your screen is two funnels allowing the data to put in, and we produce the final output as the transform data output. It's just a picture that I loaded here. This part is same as the previous videos. So we are importing NumPy as NP, pandas instance as PD, and we are visualizing the data, just sneak peeking into the data. It's the same data set. Host, if it's a superhost or not, identity is verified or not, neighborhood cleansed, latitude, longitude, property type, house, apartment, or room. Room type is entire apartment, room private, private room, or how many it accommodates, bathroom, how many bedrooms it got, and it allows guests or not. But final target variable is out of these three. So we're trying to predict the price of it. Price, if it's numerical target variable, then it's going to be 250, 65, or continuous. This is the continuous target variable. This is binary target variable in the form of zeros and one. The price is greater than 150 or not. And finally, a categorical example of the same target variable, price greater than 226, less than 75, between 75 and 150. So it's a categorical target variable. Know that we simply are showing these three target variables, but we are going to use only one of these three columns when we do the final machine learning. Now, the final shape of the data is 3,555 rows and 23 columns. Now we simply split the data in 70 and 30%. So 70% is the trained data, the training data set, and 30% is the testing data set. It's just like you get tested on the exam. So you study the 70% and something new the professor tried to present to you in the exam that's like similar to the previous data set, but actually it's new. So that's 30% new data set that we try to test our data sample. Know that we have not set the target column yet. Is null function applying on the panda data set, and we're summing those nulls and trying to see if there are any null values. There are 556 null values in review score rating, 10 null values in bathroom, bedrooms have 8, beds have 6, plenty of nulls, missing values we have got. We did this test on train, we're going to do the same test on test data set. That's a 30% data set. We got, again, a lot of null values in the review score. We got null values in bedroom, bathroom, and beds. So we've got plenty of nulls, and the proportion of nulls seems similar. So columns are similar where we have those nulls. We want to get rid of those nulls. We don't want nulls in our data set while doing the machine learning. We're going to learn how we do that in a programmatical way. Just remember, we are trying to follow this funnel methodology to obtain the transform data. We are going to impute the missing. We're going to use the one-hot encoder. And similarly, we're going to use the same steps on numerical and both categorical columns. How do we do that? So this was the conventional way that we covered in the previous video. We identified each column, whether it's a categorical, whether it's a binary column, whether it's a numeric column. So all these were numeric columns. So we put them in the numeric column list. Then these two were binaries, zeros or ones. So we put those two in the binary column list. And these were categorical, that is, they were having alphabets. So we put them in the categorical column list. We converted these categorical to numerical to play with, to make it work or make it ready for the machine learning. But now we're going to learn in this video, how do we do this programmatically using data pipeline? So train underscore inputs and data types. So all these are the data types of all our columns. So we have got ints, we have got float, we have got objects. Object represent the categorical variables. So object is room type, property type. So room type could be single room, multiple rooms, and we've got floats. Float can be numerical, but object is, just remember, it's categorical. Cancellation policy, if it's strict or not. Bed type is again a categorical column. Now, how do we do this in the programmatical way or an automated way? So what we do is, this is our data set train underscore inputs. I'm going to show you how I got that. So train underscore inputs, train. Simply, I'm using the full data set train, and I'm removing the target variables from the training set. For those who have not seen the previous video, I'm simply going to bring the data set up. So that's how our data set looks like. Host, identity verified or not, neighborhood if it's cleansed, latitude, longitude, property type, bathroom, number of guests, and these three were the target variables. These were the X variables. So what I'm simply doing is taking the full data set and getting rid of these three columns and keeping rest of the data set in the train variable. So train inputs and test inputs, train targets and test targets. So train target has the three target variables, and test target have that same three target variables. Know that we have previously split the data into 30 and 70. So train has 70% of the data, test has 30% of the data. Now, out of that 30% in the test, I'm removing the final or target variables. So I'm left with all these columns, but only 30% of it. Know that this is the random 30%. It could be these 4 rows or those 4 rows or any random 30% data set that would be sitting in test inputs. And random 70% data set is sitting in train inputs. I hope you're able to follow this. If you're not, feel free to leave me a comment. I will do my best to respond to it. So I'm selecting np.number. So all those include np. np is numpy, numpy.number. So I'm using a function modifier that is number. So if it's a number, if the column is numerical, it's going to sit in this numeric column list. I'm using columns to list command on our data set, train inputs. Now I'm only filtering in the NP number, all those columns which are numerical in nature. In the exact same way, I'm using the object, all those who are object, all those columns which are object data types would go to categorical columns. So it's a list. So these guys are in the form of Python list because I'm converting the columns to list. Know that I don't have a very good way at this point to share in this video to identify or separate out the binary variables or binary columns from the numerical columns, because binary are also in the form of numerical. So it's in the form of zeros and ones. So all the binaries are also going to go into the numeric columns. I want a separate variable or list name for the binary ones. Why do I want that? So that I could apply a different transform on the binary columns that we are going to learn a little bit later on. But I'm separating out those columns which are binary manually. So this is a small manual work that we still would have to do if we try to use this Python code. So identify the binary columns so we can pass through without transforming. So we don't want them to be transformed. So we identify those binary, and now we try to remove those binary from numeric columns. So numeric columns dot remove. So for columns in binary, so this column, for each column in binary, it gets removed with this little piece of code. So those two are binary, and I try to publish the numeric columns. So all those columns are numeric. I want to see that it does not contain these two guys now, host to superhost. So I don't see host to superhost column, nor do I see host identity verified columns. So I'm good here. What I mean by that, I don't have any binary columns in the numeric column list. Similarly, I try to check the categorical columns. So I got all these categorical columns published here. Now, the most fantastic concept is the pipeline. I'm going to define the steps that we did one by one in the previous video. That is tutorial 1 or part 1. And now I'm going to put those steps in order using pipeline. So I'm using this pipeline command. First step I'm doing is imputer. Using the simple imputer strategy is median. The explanation what's median strategy I've already given in the previous video. So I'm replacing the missing values with the median of that column. So that's my imputer. The second step I define here is scaler. I'm using the standard scaler to scale down all the values into the form of standard deviations of that data set. So this is my numeric transformer. Similarly, I got categorical transformer. Know that I've not passed the data yet. I'm simply defining those transformer using a pipeline command. So typically I do these two steps, imputing the data and scaling it down. I did this for numeric data set. Now I'm going to do that for categorical data set. So pipeline, imputer, simple imputer, the strategy is constant. And I'm replacing all those values which are missing with the word unknown. That's step one. And then I'm using one hot encoder on the categorical columns. I'm going to pass the categorical columns in this categorical transformer. Know that this is a pipeline again. So imputer, simple strategy, constant, fill value unknown. And second step is one hot encoder, and handle unknown is we simply ignore that error. So I've defined two steps in categorical transformer using a pipeline. Similarly, I'm doing a binary transformer for the binary data columns, and I'm using a pipeline which has just one step. That's just the imputer. And the strategy here, it's different. That's the most frequent. So these are those columns which are in the form of zeros and ones. So if there's a missing value in the column, so whatever is the most frequent, if it's 0, it's going to replace that missing value with 0. If it's 1, then it's going to replace that missing value with 1. So now I'm using a preprocessor. So these three were transformer. Finally, I'm going to combine a column transformer, numeric transformer output, categorical transformer output, binary transformer output, and anything beyond that could be dropped. Here is my train data set. So I'm using a preprocessor. Preprocessor I just defined here using a fit transform on the preprocessor. So all the numeric, categorical, and binary columns are in respective headers, NUM, cat, and binary. And we are using the fit transform because it's the train data set. Fit transform, what it does, I'm going to briefly go over this again. Fit transform gets the mean and standard deviation of the target variable and transforms it into how far the numbers are away from the mean. For example, 22,000 is almost one standard deviation away from the mean. That's 0.98. 22,750 is roughly 40% of the standard deviation away from the mean. And 25,000 is higher than the mean by 1.37 standard deviation. So these data is in the form of how far these numbers are away from the mean. So all these numbers are converted in the form of standard deviation. That's the work of fit transform. Now I'm doing the fit transform and checking the shape of the final train data set. It's 2488 and 66 columns, which was previously 23 columns. Now it became 66 columns. I do the same steps for the test data set. I'm using the preprocessor and transforming. Note that I'm not using the fit transform anymore because I'm using the standard deviation and mean from the train data set. So I'm simply using transform. Transform uses the previous fit transforms, standard deviation and mean, and apply it to the test data set. And that's how I transform my test data set. Again, I got 66 columns and 1067 rows. So I got my test and train data set transformed. So that was the work of pipeline. I hope you learned something new. And in the next video, we're going to jump right in how to use this data set in machine learning. Thank you.